Hi, I'm Chad Ickman. The main reason for choosing this project, or that we took on this project, was to help anyone that's physically impaired in any way. The main goal, of course, is to get all three movements, right, left, and forward, using a neuro headset. In the end, we decided to use facial expressions over EEG data. So for facial expressions, we use raise eyebrow to go left, clench to go forward, and right smirk to go right. Each of these expressions needed extensive training for them to work correctly. To train, we used the emotive control panel, which was given in the emotive epoch software. To do this, we needed to train each expression individually at first, and then once you train those, you can set the sensitivity accordingly. Once we did this, it was pretty easy to maneuver the wheelchair and we could go through courses. So this is the emotive epoch neuro headset that we decided to use for our project. It has all the necessary features that we needed to move the wheelchair. It has 14 total sensors, a 2-axis gyroscope, and it can also read facial expressions, emotional states, and real-time data.
Hi, I'm Kyle, and I'm going to be talking about the system architecture. Okay, here's a description of our system architecture. Basically, it's how and what components communicate with each other to make our system work. As you can see from the overview figure on your right, the Neuro headset transmits raw data to the WVU tablet via a wireless 2.4 GHz USB dongle that was provided with the headset. From there, the computer parses the data stream using our program. The program itself outputs directional data to a COM port that the Arduino is connected to by a USB cable. At this point, the Arduino gets the data that was sent to the port it is listening to and determines what to send to the relay module, asserting different pins for different directional movement. The relay, as its name implies, relays these assertions to the enhanced display attached to the wheelchair. They are then handled by the auxiliary specialty control built into the enhanced display to move the chair.
Essentially, we wrote the code in Visual Studio. We chose Visual Studio basically to make a simple graphic user interface. Visual Studio has Windows Forms, which is a very simple process to get that done. Since we were using Visual Studio, the language we went with was C#. So we basically wrote a class for the headset facial recognition software, and then the class was driven by the graphic user interface. The user interface takes in a user account, you submit that, and then it can run and stop the program. The actual executable file itself is run on a Dell Venue 11.
Hi, I'm Troy Thompson, and I'm going to be discussing the Arduino code. It is a simple parse and assert loop, and it basically takes the input, the output from our program. And with that, it parses the input to determine which pins to assert.
Hi, I'm Aaron Pauline, and I'll be discussing the hardware. For our project, we use a Quantum Q6 Power Edge wheelchair, and it was capable of full range of motion. It had regenerative and disc park braking, and it was also equipped with deep cycle batteries. For our circuit, we used a Arduino Mega that was run to a relay to switch the higher amount of current needed to activate the actuators on the wheelchair.
Hi, my name is Chris Dofka, and I will be covering our research and what we accomplished from the previous group. So we started by utilizing the software built by the emotive developers. Because of the delays, it was not viable. Our main goal was to use EEG data. With these tests, we conducted 15,000 lines of code per test, and we found that it was not very consistent. It was very inconsistent between each user and each day. We found that facial recognition would be the most reliable solution to this.